Cool. Hi. Thank you for having me up here. I've only got 5 minutes, so hold up the warning when I'm about 5 minutes from being done. All right, okay, it's a good warm audience. Okay, thank you. So I'm here to talk about how my colleague Jordan over there and I made ML a little more accessible to non-developers. I think, as far as I'm aware, everyone in the room has some sort of software background. We work for a software consultancy, and a client of ours came to us with a problem. And they said that they have electrical and mechanical engineers who are their domain experts, and they're trawling through just bajillions, that's a technical word, rows of data, finding patterns and finding problematic, labeling things, basically, as a classification problem. These experts were spending way too much time doing things that weren't what they'd been hired to do. Writing code, sifting through JUMP, just throwing different things at the wall to see what stuck until they could find the right rules that would surface these problematic entries. They came to us and said they want us to make it easier for them to use machine learning. They think they could encode a bunch of these rules. So we did. We are, actively. And I wanted to share a little bit about what we learned. One of the most important things that we learned was to learn their vocabulary and speak to them in their language, and then help teach them how to bridge the worlds between data science, machine learning, Python, and what they're used to, like JUMP or Jupyter Notebooks in some cases. What we ended up doing was we ended up writing some code that would wrap, in Python, that would wrap popular libraries like scikit-learn or TensorFlow to make it more accessible to them. So a couple examples of that. And now I'm going to see which one of those that is. All right, so one of the things we did is we wrapped some of the APIs for like scikit-learn, for example. This is appending to a data set that we built. You'll notice that there's a bunch of if checks. The purpose here is to find common errors, catch them early and often, and then output a more meaningful message. And I apologize, I wrote all this up in the last 10 minutes, so I don't have the error messages handy. I had to sanitize some of this because it's built for the client. But the point I'm trying to make is the error messages that you tend to see when using scikit-learn or TensorFlow or other libraries, they aren't interpretable by a non-developer. And often you can go pretty far into the process before the problem shows up. We caught a lot of these earlier when appending data, for example. The next thing we tried to do, let's see which one this is. Yeah, so the next thing we tried to do is give them the ability to use multiple learners at the same time and could then compare the results. So you can see here that comparing learners is as easy as just defining which ones you want. We just put them in an array, we run them all, and then we use a confusion matrix to help us understand which ones are working well and help us understand them. Making that easy, and there's visualization aspect here that I had to cut out. Again, apologize for sanitizing it, but making it easy to apply multiple learners so that you can see which ones are doing well on your problem domain and which ones aren't was critical to our success. And then the visualization part was also very important to allowing non-developers to be able to interpret the results, non-statisticians to be able to interpret the results intuitively. Okay. So another thing that we built for them was the ability to automate feature exploration. I think Alyssa touched on it. By the way, your excellent presentation. Thank you. Features are the things with which machine learning will churn on and will attempt to find the pattern and attempt to learn on. So what we did is often in these data sets, the tables in the database aren't what you need to find the results. I believe Alyssa described it as something where there aren't hard and fast rules, and the expert may not be able to articulate those rules exactly, but we do know that the data contains the information it needs. In this case, we found that, thank you, that we automated exploring the space. So the answer might not be column A, that might not be able to, or a couple columns might not be able to tell you enough to find the pattern or to learn and train on it, but maybe A squared is good. So we built some transforms that you can apply to these columns, and you can do the different things, normalizing them. You can do addition or multiplication and a few other interesting operations that will, from one column, they will get you something more interesting. And then we automated this, and unfortunately, I couldn't show it here, but what we did is we gave the human expert a way to sort of put some guardrails in place and say, well, I'm pretty sure these are the important columns. I'm pretty sure that viewing them in this fashion is what's going to get us there, and then we can explore the space. And more importantly, once we find something interesting in there, a key point is to be able to explain back to the human expert what transforms were done to get us there.